All right, here's an example from Binomial Series Basic. We are going to find the third degree Taylor polynomial, T3 of x for f of x equals this thing, x over the square root of 1 plus x cubed, centered at c equals 0. Okay, so the thing to notice, first of all, is that we can write this as x times 1 over 1 plus x cubed to the 1/2 power, x times 1 plus x cubed to the negative 1/2. All right, so the first thing we're going to do is find the binomial expansion of 1 plus u to the negative 1/2. All right, remember that this is an n here, right? N, you have k and n, x to the n. All right. Plus x. Okay, right. Okay, so this will be a u to the n, right? This will be a u, yeah. Okay, u. Right, because remember in the Notes and Learning Goals Part 3, we have 1 plus x to the k is this sum n equals 0 to infinity, k choose n, x to the n. Right, so when I put the u there, right, that's taking the place of the x, so we need a u where the x is there. Okay. Okay, right. So the third degree Taylor polynomial for this, right, is we're going to go out to degree 3. Okay, so we've got, okay. Now k, right, the k, this is my k, so I'm going to put it in this negative 1/2. All right, so we have negative 1/2, 0, plus negative 1/2, 1, u, plus negative 1/2, 2, u squared, plus negative 1/2, 3, u cubed. And remember, this thing does go on forever, but all we care about, because we're finding T3, we're just going to stop at u to the third. Okay, so we've got negative 1/2 and 0 there. It's negative 1/2 and 1, u, plus negative 1/2 and a 2, u squared, plus negative 1/2 and a u cubed. Okay, all right, so negative. All right, so remember that we know that negative 1/2, the binomial coefficient to negative 1/2 with the 0 there is always 1. Okay, so we can just put that thing in there, the 1. All right, so let's see. Let's write out our general formula here. We've got k minus 1, k minus 2. And how far do we go down? 1 more than k minus n. So k minus n would be just a little bit too far, so we got to add 1 to that. Okay. All right, so negative 1/2, 1. Right, we have 1 factorial. How far do we go? K minus n plus 1. So k is my negative a half. N is my 1. So we just go to negative 1/2. Right? So we start at negative 1/2. We stop at negative 1/2. We just keep subtracting 1 until we get to negative a half. But we're already at negative a half, so we just stay there. All right, so that's negative a half. Okay, so we find that this thing is negative 1/2 u. Okay. Let's figure out what the 2 there. All right, let's see. It's k minus n plus 1. Okay, k is negative a half. This is a 2. So we stop at negative a half minus 2 plus 1. Negative a half minus 1. That's negative 3/2. You can think of this as negative 1/2 plus 1, negative 3/2. Okay, so let's see. We start at negative a half, and then the next thing we go to is negative 1/2 minus 1. And how far do we go to? We go down to negative 3/2, which is negative 1/2 minus 1. That right there, right? So that's how we just stop there. So we've got negative a half times negative 3/2 over 2 factorial. All right, so that's negative times negative is positive. That's 3/4 over 2 over 1, which is 3/4 times, flip it up, 1/2, that's 3/8, positive 3/8. Okay, so plus 3/8 u squared. Okay, let's put a 3 in there. Factorial. Let's see, k is negative a half. Down to 3. Negative 1/2 minus 2. Negative a half minus 2. Let's see, what is that? Let's see, negative 1/2 plus 2 over 1. You could find a common denominator if you wanted to. You could just also do this little trick. You've got, let's see, this is 1 plus 4 over 2, negative 5/2. So we stop at negative 5/2, is also just that same negative 1/2 minus 2. Okay, so we've got negative 1/2, negative 1/2 minus 1, negative 1/2 minus 2. Right, we stop there. Right, so negative 1/2, negative 3/2, negative 5/2 over 3 times 2 times 1. Okay, so negative times a negative is a positive, positive times a negative is a negative. Overall, we're going to have negative. We got a 6. We got 5 times 3 is 15. 2 times 2 times 2, that's an 8. Right, so we've got negative 15/8. Flip it up again. Times 1 over 6. Let's see, 3 goes into there 2 times, 3 goes into there 5 times. So we get negative 5/16. So here we have negative 5/16 u cubed. All right. Now you may notice that this right here is very similar to one of the problems in the homework. You might stop it right here, find that problem, see if you can do that problem. All right, so we've got this thing now. found that 1 plus u to the negative a half is this thing. Okay, now we're trying to get to, all right, so that tells us that 1 plus whatever we put in there to the negative 1/2 is equal to 1 minus 1/2 whatever plus 3/2 whatever squared minus 5/16 whatever cubed. Now remember, what we're concerned with is with an x cubed there. So let's do an x cubed, oops, x cubed, x cubed, x cubed, x cubed. Okay, so 1 plus x cubed to the negative 1/2. Now again, remember this is approximate, always approximate. Approximately 1 minus x cubed over 2 plus, oh, well, let's leave it as a half. No, it's fine to write it as x cubed over 2 as well. I'm just going to write it like this. Plus 3/2 x to the 6th, or where we multiply those there, minus 5/16 x to the 9th. And the problem we were concerned with was with an x in front of this, so then x times 1 plus x cubed to the negative 1/2 is x times this whole thing. X plus 3/2 x to the 6th minus 5/16 x to the 9th. All right, distributing through, we got x minus 1/2 x to the 4th. We're adding the exponents there. Plus 3/2 x to the 7th minus 5/16 x to the 10th. All right, so this is x over square root 1 plus x cubed, which was our f of x. Okay, now you're probably wondering, okay, so what I think it's probably likely that you heard me say here you multiply them, whereas here we added them, right? So x times this, we added them, right? So why is that? All right, so let's look at the difference here. X cubed squared, this is x cubed times x cubed, right? So so here when you have same base, you add the exponent, so that's x to the 6th, right? So if you have it like this, you actually multiply them here. That'll give you what you want there. Notice this is 3 plus 3. 3 times 2 is 3 added to itself 2 times, so this is exactly x to the 3 times 2, x to the 6th there. Whereas here, what did we have? We had x times x cubed. There we want to add the exponents, right? So we have x to the 4th. So what am I trying to say here? X to the m to the n is x to the m times n. X to the m times x to the n is x to the m plus n. All right.